This program is a presentation of UCTV for educational and non-commercial use only.
Hi, I'm Susan Simpson, and Patty and I are working at UC San Francisco with the capital programs and facilities management group, and we're working at trying to take the UC Regent's policy and actually make it happen, turning it into kind of a reality, which it can be a little bit difficult. Sometimes we want to make it sure that it actually gets into the real form of the construction reality. Oh, yep. There we go. So
basically what we're doing is we're taking the Regent's policy and finding the path to implementation to the project managers. We know it's not an easy path, and we've been working at it for a while. And we're getting there. So, Susan?
Okay, so that is our mission, and we have decided to accept it. There are some basic rules in place for the UC Regent's policy. So we just want to do a really quick overview of what the Regent's policy on green building design is, just so we're all starting from the same place. There are three types of buildings that the UC Regents want us to do something about, have set a policy in place. The first is new buildings, and essentially the policy says to we have to improve on Title 24 by at least 20%. We are meeting the requirements for LEED certified rating. However, we do not actually have to get the LEED certification. It's just kind of a LEED lookalike, essentially, is what the requirement calls for. So, no. Okay. So then we're also striving for a LEED certification.
For silver certification.
For silver certification. We're supposed to stretch it a little bit. And also the Labs 21. We're designing and building two Labs 21. For the major renovation projects, we are improving by Title 24 by 20%. Again, we're meeting the requirements for LEED certified rating. Again, it can be like a LEED lookalike. It doesn't have to be the actual certification. We're trying for the silver. This is according to UC Regent's policy. And we are registering with Savings by Design program for all applicable projects. Then all projects, we have to try really, really hard. We have to list everything we're doing with sustainability.
Okay, so the path from implementing the policy, from the Regent's policy to implementation, just has a few steps at UCSF. So we've got our CACS committee, which is the Chancellor's Advisory Committee on Sustainability, and that feeds down into the steering committee, which is comprised of the co-chairs of the work groups. We have 8 work groups that basically were pulled from the Regent sustainability policy for each of their sections. And so I'm the co-chair for the Green Building Group, and then so we have our committee. Susan's on the committee for that. And then that feeds down into the CPFM, Capital Programs and Facilities Management Sustainability Committee, which feeds down into capital programs, and which is Susan and I. And then we meet with the project managers to implement the actual policy.
So,
Could you hit the sound, please?
sound. So what we really think is that the project managers are really, as far as construction, designing construction goes, the project managers are really where it's going to happen. It's where the rubber meets the road. Everything travels through the project managers all along the way. And if the project managers, are up to the program and on with it, then it'll happen. So what we're working on is trying to educate, motivate, kind of get the policy ingrained into the culture of our department, so that it's there and we don't have to worry about it anymore.
Okay, so the Director of Capital Programs, Michael Bidet, who's also the interim Assistant Vice Chancellor and campus architect, has provided the sustainability group 20 minutes at each monthly staff meeting. And so we set up either visitors or Susan and I, and we talk about things that are happening on campus and try to, again, assist the project managers into putting sustainability as just part of the normal project management and not have it be something special. So it becomes business as usual. So you can see from the list that we've got quite a few presentations to date. And next.
Okay, and then we also set up an education program, kind of an in-house, at-house education program for the project managers. We're constantly evolving. But as of now, we've had things like brown bag lunches, and then have vendors come in and give talks. We're having tours. We're setting up a tour of the Sausalito Marine Mammal Center that has a lot of sustainability things in it.
And then when we attend conferences like this, we come back and we spread that knowledge to the project managers that weren't able to attend.
And also a little brown bag movie program we're getting going.
So we also use outside resources. So we set up webinars through the U.S. Green Building Council. They're free, and we can get as many people as we can fit into the conference room. Again, training our staff, training the project managers to what sustainability really means.
So back to the actual project level. So at UCSF, we've actually set up kind of a 4-level of project types and what we are going to do about it to make sure that the sustainability measures get worked in. And it's from the largest of the new construction down to the humblest of projects.
Okay, so at UCSF, we've made a decision to not do a LEED equivalent, but to actually go through the process. It's like studying for the test and not taking it. So this way, all new construction must be registered with the U.S. Green Building Council, meet a minimum of certified, though we are pushing for silver internally and striving for gold. For renovation projects, that's $5 million and greater per the Regent's policy, again, requiring projects to register with the U.S. Green Building Council and go through the certification process. One of the things that we're also doing is we meet with the medical center and real estate. So we have 3 very distinct entities on our campus and working together to share the information. Right now we're trying to get the upper management from the senior management from the med center and real estate to also buy in with the requirement that all projects go through the LEED certification process.
And we have all projects over $1 million. We are requiring that they actually go through the registration with the LEED CI online. We're not going to have to push the button to actually apply, but everyone is going to register, and that's going to allow us to collect all the data, sort the data, keep everybody talking the same language, essentially. And once again, the medical center and real estate, we're working with them so that the whole campus is going to be on the same page.
And so it helps us in reporting to the Office of the President so that we do it's a full report for the entire campus. It's not just capital programs. It's the real estate and the medical center also.
And then the final level is all projects, no matter what. We'll have a campus-wide checklist that everyone is going to be working off of. determining checking out what they've done with the appropriate backup. Again, medical center and real estate will hopefully all be on the same freight car with us.
And as the UCs knows, each campus has a baseline that they are supposed to be meeting for their projects. And at UCSF, we took that baseline and then went to just very minimal for all projects, saying you have to use low VOC paints and adhesives, and really the basic requirements, waste diversion at 75%. Right. And so regardless of the size of the project, you need to implement these things without fail. So. Okay. In February, UCSF started to hold weekly drop-in sessions for sustainability. So Susan and I are in a conference room from 11 to 12 every Wednesday, available for project managers to drop in to talk about any issues they might have. Go to the next slide. And we also schedule meetings with the larger projects, so they bring in their designer, the CM if there's one available, and Susan and I will sit with them. We go through the information for the checklist and make sure that they're consistent across the board so that all projects, as we submit for some of these baseline credits and campus credits, they're consistent. So it's kind of a similar portfolio program.
Then also what we do, we have our regular checklist of the projects, the reviews as the projects go through the design and development process. So we've added sustainability as part of that normal checklist so that along the way we can make sure that it's kind of on the right track and everybody's paying attention, and we know that it's really, really an important thing to do. Yep. Yeah. Eco charrette.
Okay, eco charrette. So we're holding these, and some of them are, the eco charrette is included in an overall design charrette, again, trying to incorporate sustainability as business as usual.
Then the other thing is we are going to review all the lead U.S. Green Building Council information before the final button is pushed to make sure we're all on the same page, that nothing's missing. And also we want to make sure that we check and collect everything that all the projects have done so we don't have to reinvent the wheel. So it's kind of repository checking and collecting and just making sure everyone's on the same page.
Right. And again, making sure that we're consistent across the board so that all projects are submitting the same information. So if somebody's submitting information on the urban setting, that we have all the same information, and somebody isn't saying, oh no, we can't get that credit, and another project is saying, yes, we can. Yeah. So.
Okay, and then just a few of the other things that we're doing, additional things that we're doing with the project managers.
Okay, so contract reviews. We're actually, again, in the UC system, we're talking once a month with all the different universities. So from UC Davis, we got some information for the EDPA and the PSAs. Again, specifications, we got some information from UC Merced in Division 1. So we're trying to not reinvent the wheel and really share information with everybody.
Also, within our own department, we're trying to provide help with the UCSF-wide lead credits. I mean, a lot of the things are going to be the same across the board. A lot of the prerequisites, no matter what, they're going to be the same. They're going to require the same backup. So we're collecting that as they come along. We're actually creating some of the letters and having the appropriate people sign them off so they're there, they're ready. All the different projects can use that information.
Right, and if you're not familiar with UCSF, we have a Parnassus campus, a Mission Bay campus, and then Mount Zion campus, and then outlying areas. So each campus is going to have very specific credits. So we want to make sure, again, that we're consistent across the board and that there's a depository for all this information to feed forward. We also have a balanced scorecard measure where, again, sustainability is important to the university. We have certain measures we want to meet. Next year, our goals are, even though the Regent's policy is certified with a stretch or reach for silver, we're going for silver. Really, we're working for that as our baseline with a stretch for gold.
Other thing we're doing is we're working with the Center for the Built Environment at UC Berkeley. They have a pre- and post-occupancy surveys set up. So we're requiring our projects to go through that. That way we have a really good way of tracking and reporting preconditions and post-conditions and seeing how well our changes helped the people's comfort and other things related to the projects.
Okay, and again, we've asked our project managers to invite either Susan or I to their kickoff meetings.
Oh, music.
What? Is that it?
Yeah, music.
So invite us to their kickoff meetings so that we can talk to the contractors directly about the waste diversion and how they go about it. In San Francisco, it's actually mandated so that the debris folks actually do some of that waste diversion for them. So it's easy. And again, to talk about that the sustainability measures are incorporated throughout the specs. It's not just one little section in Division 1. And to just make sure, again, that they're on track, that they understand that they have to report back to us because we have to report to somebody else. So.
And then the last thing is when construction is complete, we kind of go back and review things and make sure it really happened. Make sure that the things that we actually required in the contract documents were completed. Another thing that we were actually having a little bit of trouble with, it's a small thing, but we have a waste diversion requirement that's been there for quite a few years, and we were having trouble actually getting the documentation for that. So we're requiring now that before the notice of completion is filed, we actually have that in our hands. So I think that'll just take care of it. That's probably the end of it. It's going to be the end of that.
No waste diversion reporting, no retention. So.
And then we are thinking about how we can make actually the lead, meeting the lead requirements, actually working that in with the contract and final payments. That's something we're thinking about and trying to work on at this point. And then hopefully all the pieces are in place and we'll just keep improving and working on it. So, music.
Yeah, it didn't work.
Oh, I can't hear
okay.
it. All right. Okay, well,
So
that's it for us.
questions?
No?
Questions, yeah. So how do you want to?
A viewer from Ursinus College asked what are eco charrettes?
Oh.
It's basically your sustainability charrette, where you get the clients, the facilities folks, basically all the stakeholders in a room and hash out what's important at the beginning of the project so that further on when you're doing value engineering, the things that were important to you back in that charrette are still maintained, and that you can go back to that and say, well, we really wanted to focus on energy savings so that you don't make just decisions based on just dollar value. So. And there's a question over here.
I was wondering, sort of outside of the purview building per se, that there's a great opportunity for medical capital equipment vendors being a research facility and procedures, the whole process. Additionally, ways of reducing the occupancy of the building and its purposing, including medical procedures and medical research, further reducing.
Can you hear that? I can't.
Well, I really can't answer that question. Susan and I are on the campus side of things, so we actually focus on the research buildings and the lab buildings and not on the hospital. But if you give me your card afterwards, I can connect you with somebody who may be able to
Yeah.
work with you on that.
Because we're working with the medical center and real estate who are kind of have their own design and construction groups going. So we're trying to do a hands across the campus type of thing, but we definitely are kind of a separate little group at this point. So,
Okay, did I hear you say correctly that if contractors don't have documentation, if contractors don't have documentation for their recycling content, then they're not getting their retentions?
that's correct.
Well, no, it hasn't
Kind
been
of,
implemented
kind
yet.
of.
We haven't figured out how to do
It's
that.
actually in our it's in our construction documents already.
That was my question. Has
Yeah,
that
so
been
it's when it's in
legal?
It's in Division 1, and it says, here's the form, fill out the form, tell us where the waste went. You have to do at least 75% waste diversion.
We haven't implemented it yet.
As far as the retentions,
Right.
what I'm thinking is that you need to put a dollar value on that. Legally, you have
In
to
the
pay
schedule of
retentions.
values,
Yeah.
it'll be a line item.
Exactly.
Okay,
Yeah,
that's-
that's a really good
That was my
way of doing it, yeah.
Do you want to take a, do you have another question?
How long do we want to, do we have a minute? Okay. So we need to save time, I think, at the end, yeah, for other people.
Carl Sherrill has written and said, has change orders and scope changes after the contract document issue been a big deal in your green building programs?
Repeat the question.
What?
Has the change orders increased?
After the contract document issue been a big deal in your green building programs?
Okay, so basically have our change orders increased in the green building program? Actually, they've gone down, because one of the things that we've started to implement is BIM, Building Information Modeling, so that it helps the coordination process prior to actually construction, so the change orders are going down.
Unless the question is actually, I mean, because someone can come in, you know, kind of slip in under and do a change order that kind of takes everything away. I mean, I think that's probably what that question was, and I don't think it's been an issue.
No.
Yeah.
No.
And the last thing that somebody wrote in was just that for the future speakers, if you would repeat the questions so that.
Yeah.
Okay.
Good.
Yeah, sorry.
Okay.
Another question, there was a gentleman, yeah.
This is the last question.
Okay.
Why you're not actually officially going for LEED certification?
The question was, why are we not actually going for LEED certification? We
That's
are.
only for UCSF, that is only for projects under 5 million. For projects over 5 million in new construction, we are going for LEED.
But we're not going for LEED for projects for 1 million to 49999. Because some of the smaller projects, it could be cost prohibitive. But they're still, we'll document the credits that they obtain, and we collect that data.
And frankly,
submit it.
some of them just aren't applicable. I mean, just there's no way. You know, if it's like a HVAC project, it just doesn't like fit into the mold.
Right, and some of
But
our
we can
buildings-
still register them and collect what we can.
Right. And some of our buildings prohibit the commissioning, fundamental commissioning, so that right there says they can't.
Gotta go.
Okay, Patty and Susan.
Thank you.
Thank you very much.
So the usual in sustainability of the many chapters of sustainability that we do focus on at Stanford University, green buildings is one of the topmost priority, not only because it's the most visible one, but also construction-wise, Stanford has experienced the largest amount of growth in the last 5 years, and the next 5 years are continued to be projected to have the same amount of activity on campus. So the discussion around sustainability, the way sustainability is incorporated in the design methodology, life cycle costing, it's a very important conversation going on campus right now. So we'll focus on that. So Heartbeat, a little bit of context, and this is Stanford's tried, tested, proven process for new construction. And it's the different phases. I know you can't quite read the writings, and real quickly, it's scoping, feasibility, programming, schematic design, design development, documentation, construction, content, and of course, to the point where a new building becomes an existing building, the owners take over. But this roadmap for implementation has been there with Stanford since 2001, that contractors, consultants, and all the teams that put together the actual project that eventually reside on campus really follow. And the joke here, of course, is that the heartbeat is never as even as it looks. There is arrhythmia, there are occasional strokes, and not the perfect picture that I'm showing you right now. So a little bit of all the different guidelines that exist on university and how they have influenced each other. 2001, that's the heartbeat process. It's board approved, and only the board of trustees can actually change that process. Again, it's universal, that works for all small to large constructions on campus. We have the sustainability design guidelines for Stanford that actually came into place in 2002. And are you not hearing me okay? Okay. And it got revised in 2008, and we'll end with that tone and the impact that LCCA has on that. Along with seismic design, project cost and efficiency. And of course, the guidelines for LCCA got developed in 2005. And since then, every project management process really reviews that particular guideline. So LCCA, I believe, Cole and I chatted, and we wanted to make sure that it's It's the cost analysis portion of this process that's really in question here. This is not necessarily a holistic sustainability analysis where we look at, the cost, the equity, as well as the environmental impact. So it's life cycle cost analysis. And perhaps the most important piece of this process is what it informs the project management decision making is the trade-offs between the projects that may be low cost and easy to do now versus the long-term ones that have greater environmental benefits. And in LCCA, we have found that trade-off decision process to be most useful. Back to the heartbeat. And just to show you real quick where in the process LCCA plays a really strong role, it has its presence in scoping, feasibility, programming, all the way to ownership, but mostly in feasibility programming and in schematic design. In the 4 bubbles basically stand for the different elements of typical sustainability chapters that we know of in energy, in water, building envelope, and others that LCCA decisions really make a difference. And the next picture will put that in perspective. So this is our matrix. Whenever there are decisions and trade-offs, there is a matrix. In terms of the 7 different categories that I will quickly show you, there are 15 possible combinations of this analysis, and the decision matrix puts it in perspective for the project team that's comprised of different stakeholders to make a decision on which one that particular project should focus on. So on the high, it's the simple analysis, and potential cost impact could be higher, and at the bottom, the potential cost impact could be low, but it's very complex analysis. So you can imagine it's the mask of Zorro. It's the Z pattern that the project team focuses on at all points. And when you put that on top, we have the energy systems, mechanical systems, electrical systems being most common ones that are done first, and you can imagine why. The return's always more favorable. The siding and the building envelope are most commonly done now, especially since 2005 onwards. I would say it's really been part of the design process. The structural systems on and off depending on the project, and the water systems being the most popular one with all the processes that are happening now. So right before I introduce Cole Roberts, this is sort of the subject, the Y2E2. It's not R2D2. Y2E2 stands for Yang and Yamazaki Energy and Environment Building. It's our anchor building on campus that has the highest sustainability standards in terms of energy systems, water efficiency, as well as the building envelope and the look and feel of the building that is really standing tall at Stanford campus for interdisciplinary research. So the reason why we talk about that and we focus on it is the life cycle cost analysis. It's not just that something that became important to Y2E2, but for the whole complex of about 500,000 gross square feet of fine space on campus. So with that, I'm going to let Cole Roberts, our partner in crime, to walk you through the future of the process.
Okay, does this sound good? Okay. So the Yang and Yamazaki Environment and Energy Building, a quick picture of it. One thing that we wanted to highlight is that if you remember those guidelines that Famita referenced earlier, the life cycle cost analysis guideline was formally published in 2005. This building and the engineering quad in general started planning and design in 2003, 2004. So this was really a case study in the application of the life cycle cost analysis guidelines. The matrix that Famita referenced, the prioritization matrix, here's all of the different life cycle cost analyses that were done in detail for the Y2E2 building. We're going to highlight specifically the whole building analysis because we think it's something that's really never been done before on quite such a comprehensive level in today's presentation. To start that off, we wanted to highlight, of course, the fact that we did need to know the first cost premium related to the energy elements within the building. That was a part of a larger effort to identify the sustainability cost premium in whole for the building. Energy was broken out insofar as the strategies that were required in a prioritized fashion, those that reduced the load in the building, those that were primarily passive in operation, those that were efficient but active in operation, those that focused on an energy recovery element, those that were generative or renewable sourcing, and then the offset component, so a carbon purchase agreement. At inception, we wanted to highlight a roughly schematic design. We were carrying about a 10% premium on the cost of the overall project for all sustainability elements. It was clear as we moved forward and the integration of the elements, the design elements into the building became more pronounced and more deep, that they could not easily be extracted, and therefore there became a low, a medium, and a high estimate associated with many of the strategies. That therefore became the risk range, and by the end of the project we had actually converged to a low estimate of the premium at about just squeaking under 1%, at a high just under 5%, and a medium at about 2.5% premium overall. Energy was then a subcomponent of that. We're going to highlight the medium in today's presentation. This graphic highlights the payback threshold for step one, reduction in load. Reduction in load were a lot of the facade envelope improvements as well as the lighting power density reductions within the building. On the far left-hand side, you'll see the cumulative cost versus baseline. That's roughly a measure of how much additional investment was required on the project in order to implement the strategy. So it's a marginal cost. For example, here we paid a premium of about $650,000. As it pays back over time, there are savings, crest and break that red line at about 6 years. Really, it's somewhere between 5 and 8 years. We'll talk about ambiguity a little bit later, but it's a fairly steep curve. Passive systems, this was primarily natural ventilation and daylighting for the building, was a cost credit, meaning that we actually eliminated some systems in the building, carried a credit forward, and it was above the line, meaning roughly about a $200,000 savings. But a very flat line, so highly sensitive, actually, to some key variables that we'll talk about later. The active systems were a little bit of a surprise for us. We thought they were going to be more in the 8 to 12-year range. They came in about 2 to 5 years. The building has an active chilled beam conditioning system. It also has a radiant floor that you can see up in the upper right. Energy recovery was primarily in the air handling units. This is largely a laboratory building. So for those of you who aren't familiar with heat pipe technology, we're recovering heat from the exhaust airstream of the building, transferring that heat across to the incoming airstream in order to condition that prior to hitting the coils in the air handling unit. You can see that that paid back in roughly 8 to 12 years, again a fairly flat curve. Photovoltaics were implemented on the building. The yellow line here highlights just one of the photovoltaic technologies that was considered. There were actually a total of 8 different life cycle cost analyses that were done for photovoltaic technologies. Some actually paid back in as quick as 8 years. But we're not going to go into detail. The one that this highlights actually never paid back. It was an infinite cost. So not an infinite cost, but an infinite payback period, and therefore never paid back. Green power was interesting because, of course, it carried no first cost premium. It was just an ongoing utility contract or purchasing contract through a third-party provider, but always then had a cost that carried forward. The interesting thing is that what we did was we agglomerated or combined all 6 of those strategies into one assessment, a whole building assessment, and that's what this red line conveys. So if you take all of the energy infrastructure investments in the building, they were seen to pay back in roughly 4 to 8 years. This is highlighting a little under 5 years. That was an extremely convincing argument for Stanford to do some things later that Famidia is going to talk about insofar as raising the bar campus-wide. There's a lot here that you're not seeing because of the limited time frame that we have. We ran low and high cost scenarios because I did mention there was a low, medium, and high. We ran optimistic as well as very pessimistic scenarios to see how the results would change. We did some break-even analysis. We also looked at what were the critical variables, energy escalation, maintenance, things like that. And although we didn't quantify a lot of the costs associated with intangibles and externalities, we did always include a detailed discussion in all of the life cycle cost analyses that were carried out. There was a written discussion associated with them. The success factors, we're going to highlight just 3 of them here today. The need to recognize ambiguity, and I'm going to highlight that in just a moment. The commitment to cost convergence, we started out at 10%. We ended up somewhere between 1 and 5. The value commitment, if a project team can show at Stanford University a payback threshold under 10 years, it's written in the guidelines that implementation should go forward. So that commitment on the part of the university to basically have a forcing mechanism in their guidelines is very strong. Do we have any accountants in the room? Okay, so I get to make jokes. One joke I'd like to say is, anybody know the difference between an accountant and an engineer? An engineer is approximately correct, and an accountant is precisely wrong. I think we realized that in the recent economic turmoil, right? So anyhow, the focus here is that ambiguity was actually, we knew more because we knew that there were things that we didn't fully control. And all of those low, medium, high cost scenarios, the optimistic, pessimistic, all of that was actually very important to making a good decision. It wasn't one answer. Also, the importance of considering the intangibles and externalities. The life cycle cost analyses at Stanford don't say you can't make a decision that doesn't pay back. So if there is some strategy that has very strong reasons to move forward with, maybe due to entitlement reasons or the health and well-being of the employees, there's certainly a means to incorporate intangibles. The second highlight that we'd want to focus in on: prioritization, expectation, and timing. 10,000 decisions for Y2E2 to go forward, plus or minus a couple thousand. 7 detailed life cycle cost analyses. So we did not do a life cycle cost analysis on everything. We did another 13 or so, probably back of the envelope type stuff, but we prioritized them. And not all of them were in SD, as that arrhythmia and that heartbeat tends to happen, right? The focus of those 7 life cycle cost analyses actually were early as well as somewhat mid. So SD, DD, even a little bit into construction documents. And with that, I'm going to turn it over to Famita and wrap up.
And I was just told that you guys couldn't hear me because my microphone didn't have that little cushy thing. So the last 2 slides are going to be really, really good, right? The steps going forward with all this analysis, I mean, analysis is always an empowering or informative tool. One challenge that lies before Stanford University, of course, is the different projects that are doing life cycle cost analysis. We should have some sort of a knowledge library. The components for each of the projects, although 2 projects are never the same, but the bigger pieces, for example, the Graduate School of Business with its brand new campus, which is striving for LEED Platinum, as well as the new Stanford Law School. There's a concert hall being built. Each of them are doing at least 5 to 7 different LCCA that we are aspiring to put in a knowledge library, and hopefully not just for Stanford as well. And the final big picture, as I was showing you sort of the aspects of sustainability, and we're focusing on green buildings right now and LCCA, the LCCA process has actually informed the campus of much bigger decisions to come. So much so that the process that we do, that we kind of like a different version of that when applied to the campus analysis, we identified that the campus overall could strive for 30% more energy efficiency and 25% more on water compared to Title 24, which if you do a LEED equivalency, it's LEED Gold equivalent. So that kind of an insight, it's not randomly chosen. It needs some sort of an analysis tool to go behind it. So LCCA for us is not just a method to analyze trade-offs, but it's actually completed the picture by being able to inform bigger decisions on campus, or what are some of the standards for other buildings that we could strive for, whether it's Y2E2, the law school building, the Graduate School of Business, concert hall, but all the constructions and major renovations to come in the future. So thank you, Cole, for partnering with me, and we'll just take a couple of questions before the next round, I suppose.
You want to coordinate? Sure. Go for it. Right here on the far right. Well, we'll repeat this first question. So the question is, with 30% less energy, is that going to be based on the new Title 24-2008 or an older standard?
This is based on, right now, the older standard. The 2008 Title 24 calculation hasn't been done yet, but we don't expect it to be vastly different for the campus. And yeah.
Next question. Sorry.
Yes, so you complete a life cycle analysis, including a PV infrastructure investment that had a finite payback period, and how'd that affect the overall whole building payback analysis?
So actually, I don't understand the question. Can you ask it one more time? Okay, and you're wondering if we actually did a life cycle. So the question is, did we redo the whole building analysis with a finite, or with a photovoltaic analysis that was actually better, a photovoltaic analysis that didn't take forever to pay back? So I can answer two things. One, we did do, we actually never did a whole building photovoltaic, and we never did this analysis with a photovoltaic system that paid back in less than 25 years. That said, with confidence, I can tell you that it would not have significantly shifted the red line. You can see that actually this photovoltaic array has a very flat line associated with it. It does not have a very intense energy output. This is actually a thin film system that we were looking at here. Even the most aggressive photovoltaic system we had, probably it would have been less steep of a curve than the pink line. So it's somewhere between the pink line and the yellow line. So it wouldn't significantly have shifted it, maybe 2 months faster, something of that sort. Just to give you a sense for that, we did do a carbon tax scenario test on this. We priced carbon at $30 a ton and saw how that would change. And we actually showed, maybe you actually can pull that up. It's going to go really far. Keep going. It's right here. So this was without it, and if you go one more, this was the shift with it. So the carbon kind of overarching picture that we're all kind of wrestling with would have shifted this analysis by about a year. Am I going to? I don't know if Michael, if you're.
I'll do the next. I'll take the mic around for people.
When the project appeared to have a 10% cost premium at the start, perhaps because the sustainability features weren't integrated in the design, how did you convince the team to go forward?
So it's an environment and energy building. So it was a natural. There was of the 4 buildings in the engineering quad, this building was identified early on as being the platinum equivalent one. So it was going to do very, very well. It was kind of the beta model. And it was not an option to not achieve those performance targets. So they did actually, well, there's a whole long story that goes with how we got to under 5%, but, and we could go there if you want, but it wasn't an option not to proceed forward.
I'm wondering, were you the project manager? And if you were, could you talk a little bit about how the owner, in this case, interfaced with the design team, the architects and the MEP, in terms of producing the LCA? Thank you.
I was not the project manager. Neither was
Neither
Ramita.
was I.
I was the project manager from the consultant side, so I'm with Arup. I can talk a little bit about how the owner, how the project manager, Maggie Burgett, interfaced with the architectural and engineering team. She was amazing. She was absolutely, I would work with her on any project ever again. She did 2 things I think that I would highlight. One is that she drove the project. You can't depend on your consultants, I think, to drive it. That driving force really has to come from the owner's representative insofar as their commitment. And the other thing, she tolerated ambiguity, right? We all love to get an answer, one single answer. And she was very tolerant of the notion that some things were a little bit fuzzy. And that actually ended up, I think, making the overall project a lot stronger.
Yeah. Judy, so this is not for the Y2E2 project, but it's a similar diagram for another, the Graduate School of Business project of the team's interaction. And what Cole said about the insight and personality of the PM can make that vast difference. And Maggie, before our presentation, when we were prepping for this, she said, I told Cole, be my environmental conscience. And that's a tremendous delegation and trust and friendship that many other projects may not get to experience. So that's why The Y2E2 story for us is success story at many levels. And the other piece is the way the design team was put together from the start is faculty was very involved from the beginning. They had a real vision of what that building was going to be about and how faculty, along with other uncommon stakeholders, were going to be a part of the process from the start. So every single time there was the decision point, they made sure that the partnerships came about. But that's a similar diagram with the construction team, design team, core technical team, et cetera. Similar diagram that's being followed for the Graduate School of Business project, which is also doing a bunch of LCCAs.
This will be the last question because we have to move on to the next part of the program.
You showed the chart up to 32 years. Does that mean life of the building is 32 years? Is that what the analysis was?
No, so most of our life cycle cost analyses, we will pick an analysis range, and that'll generally be from 25 to 40 years, depending on the technologies and strategies being tested, since many of them will have increments of life cycle expectancy within that framework. They may have a 12.5-year or a 15-year life expectancy and therefore have to be replaced halfway through, or they may have a 30-year life expectancy. It's just a module by which to do the analysis. The building is intended certainly to be a 100 to 200-year building.
Yeah.
Question on the web?
Yes. One last question from Dennis. Can Stanford make the slides available?
Sure. The same, I'm sorry. Yeah, no, this is public information. Sure. So these slide sets are actually being posted on the web, I suppose, and anything we've disclosed here is meant for everybody.
Amita, you might mention that all of your guidelines are available on the Stanford website to the general public.
Right, thank you. Sustainable.stanford.edu is a site that breaks down the sustainability projects by chapter, so that's one way to get to buildings. And if you want to go directly to the documents, it's lbre.stanford.edu, which is our father department, so to speak, and they have a document library. lbre.stanford.edu. Land, Buildings, and Real Estate is the largest operational department on campus. It also hosts sustainability. Thank you. Thanks, Paul.
I'd like to welcome Roger Bolton and Gary Dahl.
Good morning, and certainly a distinct privilege for me to address a group like you this morning. What I wanted to describe to you is a project we're involved in at Davis, and Gary will co-teach or co-speak with me, that involves a special design, which is a research facility, a functional teaching facility, and an example of what's possible in an industry which is a department tied very closely to an industry, and this happens to be the wine industry of California, and that's what I want to talk about. So I want to give you a little bit of background about the program, want to talk about the institute that it's in, the Robert Mondavi Institute, talk about the professor, that's this guy, talk about the Winery-Brewery Food Science Lab project, give some examples of what I call green building conflicts, and this again is a faculty person's opinion of those conflicts from the outside, and then talk about some observations in my experience through this process. So firstly, the program. The Department of Viticulture and Enology is the oldest in the UC system. It has a history that's almost 125 years, and it's a reference program for the world in terms of curriculum and research. We often say that people from this department are no more than 2 degrees of separation from anybody in the world of wine. And you might want to think about the implication of that, but it's very profound, and it's a very special place to be. There are 15 faculty. We often graduate 45 undergraduates a year, about 15 master's people, maybe 5 PhDs. So it's a relatively small academic program, but a very special one. We currently maintain 2 vineyards, one in the middle of Napa and one at Davis. We operate in a 70-year-old winery, which is pleased to hear Cole talk about 100, 200-year buildings, but you want to come and see the 70-year-old one, I'll show you what it looks like. And then talk about our research directions as a department, which are really sustainability and flavour. And that encompasses everything from grapes to wine, not just wine. So the institute we work in is now the result of a gift from Robert Mondavi. And I don't think I have to explain who Robert Mondavi is. It resulted in co-locating two departments, viticulture, enology and food science, together in a campus and a grid and a complex. And now we're in the process of building the last stage of that, which is the brewery, the winery and the food science labs that go with that academic program. Okay, so that's the winery complex I want to talk about today. This is Mr. Mondavi, for those of you that haven't had the chance to know or meet him. This is the complex that exists right now, which is, we call it the Rob Mondavi Institute. And where the photo is taken from is a sort of about the southwest corner, which is where this structure we're about to talk about now will be located. So it complements a square almost of this, site on campus. My background is in chemical engineering and fermentations and a few other things. I've taught a class on winery design for almost 30 years and involved throughout the world, as well as in California. Fortunately, in the position I'm in, I have many former students who are also friends. And so knowing 1,500 people of influence in the wine industry is really quite important when you go to speak to people about friendships and why this program goes forward. The project is this complex. It's a 3-part animal, and in fact, the winery, a research and teaching winery. So we actually have teaching labs, we actually have research experiments, and we're making research wines for people who've done vineyard experiments. Okay, that's just what the research group in the winery does. A similar kind of thing in brewing, but not as extensive into the plant world. And a food science laboratory, which encompasses dairies and other aspects of food processing. The base project is 3.5 million, with a 2.1 lead enhancement to become platinum. The general contractors are B&B Norcal, the architects are Flad and Associates. Mechanical is Frank Booth, Red Top, so forth. This is the group, the team, which is the winning bid of the design build competition. One view from the northeast corner towards the winery section, which has now got lots of light emphasis, teaching classroom, functioning fermentation and a few other things, but essentially single story, fairly integrated design, a lot of features we don't have time to go into. But in southwest Crow's Eye view, this facility will be fully voltaic. The intention was that the winery would be solar at peak load. I'll just repeat that. I believe it's important to understand peak load photovoltaic, and that's what we're talking about here. The rainwater capture is actually in a parallel session. People are talking about water use, and I think others. This is for landscaping of this building as part of lead components. Quite separately, we have interest in rainwater capture for cleaning water in this structure. That's quite outside the construction I'm talking about this morning, and quite outside of lead. But you can imagine having a winery operated on rainwater and being able to use water very efficiently. That's another story. Let's just back to this one. So the top left structure is the winery. The second lower part is the brewery and the food science labs, co-joined completely under the building complex for lead platinum. Some elevation shots. As the wine person, the only building that's important is the winery one. But you can get a sense of how it's laid out, and some side views of different orientations. Essentially, looking at the bottom here, sort of a barn external photograph view at ground level. In the bottom slide here, at the very section here, this is the winery, this is the brewery. The doors and the windows of this will look directly west. Directly west of this structure is a vineyard. Okay, can you understand the placement of a vineyard and the building and the connection of them in the complex that I'm referring to? It's a very special place. The winery itself will be mostly a fermentation cellar with 150 individual research fermenters, a lab meeting classroom, a barrel room for aging of wines, some controlled atmosphere rooms, equipment storage, laboratories and offices, and this is the brewing food science part. A research bottle collection, and these are the doors, and this is the west, and the vineyard is here. I hope that gives you a quick sense in the time we have. So here's the graphic of the vineyard and the doors of the winery and the brewery adjacent. My role is twofold, has been twofold in this project. One is the concepts from the design of wanting it to be a lead building from the beginning, wanting to introduce green chemistries into our practices, wanting to make it self-sustainable in water and energy. Okay, and those are personal ambition goals. Trying to control our fermentation environmental conditions very precisely. So this entire fermentation cellar will be a wireless network, the largest wireless network in a research facility I know of. Again, there's no lead points for that, but those are important principles in my world. And I want it to be web-based learning. We currently run our fermentations on my laptop and I can view them anywhere. I want them to be not just available to people, I want the entire systems of this facility to be on the web in real time. I want it to be a live building. Yes, I want it to be a live winery, and it'll be the first of its kind. The other was development of fundraising and trying to fund some of these aspects, which is where I get back to the friendships with students and company owners. And so in order for it to be LEED Platinum and get the enhancement, required additional funding that wasn't available at the beginning of the project. And that began by getting budget estimates of what that would take, trying then to go back with particular groups and raise funds to get those contributions to build that enhancement fund to make that possible. And this is going in parallel with the design, build, construction stage. Sorry, let's go back. So I'll be honest, I wasn't a fan of, I'll try and go back. I wasn't a fan of design build because in the development world you need plans and sketches to talk to people about. You can't wait until you've chosen your team and you're ready to construct to go back and now talk about how to raise money for it. Can you see the dilemma in a development world versus a construction world? And I was jumping those two hurdles, if you want. And essentially for those reasons, again, we didn't want it to be linked. It would have been nicer if it hadn't been linked because of what you could talk about, but that wasn't I didn't have those choices. We went ahead with what we went with, and that's what we'll talk about. Some conflicts. I tried to pick 4 examples, one that we lost, two that we won, and one that's sort of the jury's out on, but initially we wanted to have a below ground building for temperature control, just to have completely minimal energy requirement to keep temperature controlled constant in this building. For aging reasons and all of the other things. And there's a tradition in the world of wine to have things underground in areas that have low resources. And you can go back 100 years or 1,000 years to see that. We lost that one, and it's an above ground building. Doesn't matter, it'll still be LEED Platinum, and it'll be a very exceptional building, but you can imagine if this had been almost an entirely underground building. That was one of the dreams. The campus wanted it to exceed Title 24 and be a LEED equivalent, as we were just talking about. We actually wanted a LEED Platinum certification. And again, it's a little bit of a difference in just what is the focus of that. We wanted to be fully self-sustainable in power terms as a principle. There were very few solar systems on the UC Davis campus. We can talk about that. But and we wanted to be self-sustainable in water. So we were faced with chlorinated, hard, reconditioned water, and the option was for the rainwater capture. So many of these things were somewhat at conflict with the design build and the project manager's task to get the thing done, and that's what I'm trying to address. The parent, is I talked about a very special academic program and a very special set of needs, and now 2 buildings which are very heavily food-based and sensory in chemistry. So the things you do to just get something done are a little different now because if you have an aroma defect in everything you do that's related to your building, it's critical. Okay? There are very few other buildings that I know of that are built like that in academic circles. So it really was a challenge, I think, for a campus. We knew it, I suppose, but we probably didn't communicate it very well. And in a project manager's point of view, someone says, well, you can't do that because we don't want the chlorine going down the drain to give us TCA back in the aroma in our wines. And the answer is, well, we do this in every other building. This is not in every other building. This is a very special one. So some of those things were our awareness, and how do we communicate those into the planning stage, into the design and build stage. The sanitation and cleanliness are critical, and there's a lot of codes related to food products that aren't in normal building codes. It is being used for both teaching and research. There will be a lot of people going through it, both in a teaching mode and a research mode, and we've got to juggle that. There are a lot of other buildings that have got teaching space and research space, but don't see anything near the traffic and access in the research space of the teaching role. And these are embedded together. It's also very seasonal. So a lot of the requirements for 6 to 8 to maybe 10 weeks of the year, and then very little activity the rest of the year. And it has a US and global interfaces. There are people all over the world that want to come to this facility, that want to come to speak and meet with us. So this is a very important global building as well as a campus building. It's entirely privately funded, and in the UC system that's very rare. In fact, so rare, I don't know of many other examples. The point is now who's the client in this situation? How do we handle, as a project manager, who owns it and who's the representative and those kinds of things in a traditional campus system which is not like that? And you can imagine there was a few hiccups along the way. Who decided how green it would be? And what it got down to was almost by default and having to reconstruct who was going to say how green it would be. And again, from a UC point of view, how do we understand and manage that better from the upstream? And that was also a commitment at the administrative level, who may not understand many of these things. And I suppose from my point of view is trying to understand, as a faculty member who does promotion dossiers and grades students and writes research proposals for federal grants, how to actually interact with a project manager and understand what a project manager does. And very few faculty have that opportunity, and in fact, I would suggest need to know that much better. So, sorry, I missed one there. Some differences in vision between what the campus wanted versus what the department wanted, and they get down to this, we would prefer to continue fundraising and development work rather than build. Other people decided to go forward. You can see the conflict. There was other people decided to join the buildings. It didn't make sense to us, but there was a possibility and we went forward with it. The campus chose the design build for good reasons, but it was probably incompatible with what our department wish was in the fundraising world. And the campus wanted me to exceed these conditions, and we actually wanted LEED Platinum. And so you can see the weaving that's gone on, which has been very healthy, because in general I've just described to you where we are. Some quotes, and don't be offended, but you might have heard some of these. Solar systems are not paid back. Cole, I couldn't understand better your point you're making. That's not why we're doing them. If we did them for payback, as Cole indicated, you'd never do them. That's not why we're doing them. And you can see in this building how important it is to have it. We'll pay elsewhere for the privilege of doing that. Centralised systems are more efficient, and by the time you pipe things a long way underground and get a significant heat gain, sometimes they're not. And as an engineer, I'll tell you that. But buying carbon offsets is an appropriate way of doing it. The world I come from, a footprint's a footprint. You don't get to rub part of it off. You actually have the footprint. And you can understand where that one went. Conditioning well water is cheaper than rainwater capture. It is. But, like the PV, you're going to do it for other reasons, and there's a strong principle of conservation, of reuse, and of self-sufficiency which drive those choices, not what's the cheapest. Okay. Rebates will help you achieve your energy goals. No, they'll help somebody else who's offering to you achieve their financial goals, and it may not be the same thing, and that's true. They're often not directed at what your interests are, and you can imagine this project as an example of it. LEED certification is an expense, a significant expense, and likely reduce the project. And what I can tell you, and I think Gary will agree, this project is on track, and it is on budget, and it is LEED Platinum. So it will be the first platinum winery ever built. It'll be the first platinum building on the Davis campus. It intends to be fully solar, the first in the world. It's privately funded, and the enhancement was completely done without interrupting current project and budget. And it intends to be a zero carbon building, self-sustainable in both water and energy, full carbon entrapment, and eventually sequestration on site. So, just in closing, I want to acknowledge some people. Obviously, Robert Mondavi, now passed away, but had a major role in the initial donation that led to the creation of this winery building. A similar matching grant from August Bush Foundation for the brewery. Two particular individuals that made significant contributions the early stages of the winery. Jerry Law and Diane Miller from Silverado Vineyards and Jay Law. Jess Jackson and Barbara Banke from Kendall Jackson, who were instrumental in giving us the funding to get the lead enhancement estimates. And then when we went back to them, were the major players for the first gift that got us to the lead enhancement, that then allowed us to get a matching gift, that then allowed us to have another requested discussion. And the importance of leadership in doing that got us there. The wine group being one of the partners with Jerry, the Jacksons and Barbara, and getting lead enhancement. But there's many other people who've contributed to this project, financially and otherwise. The Vice-Chancellor, John Mayer, who's, I think, come a long way. And I was critical of John in the early days, but I'll be very laudatory of him now for the movement and the growth he's shown and the tolerance and acceptance as we've gone along. And I think that's been crucial to get us to where we are. Julie is our project manager and is in a parallel session, unfortunately, but Julie, like your reference to your project managers and the importance of them in being able to delegate and say, can you go and find some information about that and come back? And Gary will address it as well. When does the project manager take time out and try to get a better solution and actually can afford to by time or budget and still come back and go on? And when's that disruptive and when's that actually helpful? And Julie, I think, has finessed that very well. Gary, who'll speak in just a minute because he was involved in much of the pre-planning and specifications for, in fact, the competition. And Bill Starr, who's also in the Architects and Engineering group at Davis, and my colleagues. At the end of this discussion will be the last part of the continuing education program, and I was asked to put this slide in. So thank you for your attention. Gary will now come and make some other comments, and then we'll answer questions you have. Thank you.
The involvement of Dr. Bolton and his faculty colleagues was absolutely essential to realizing the very ambitious sustainability goals of this project. That involvement is often rare on our campus, and I wanted to offer just a few thoughts about that issue. As he mentioned, my role in the project was in its earlier incarnations as project manager. And then I was also very involved in the latest incarnation doing the programming, and it now has a new project manager. The faculty in the system is obviously very involved in sustainability issues in terms of research, teaching, and so on. They have not been that involved, in my observation, with development of policy in the capital program area. The UC Regents policy that Susan Patty talked about earlier was adopted several years ago by the Regents, mainly at the instigation of the students, with also some very fine staff work by some people at OP, including Michael Bidet, the moderator of this panel, but very little involvement, I think, on the part of the faculty. At the campus level, at the Davis campus, I think that's also been true. The driving sustainability beyond the minimum requirements of the policy has been largely based on the interest and commitment of the individual project managers. And that has been fairly intermittent. Some projects are just going for the bare minimum, others are going all the way to LEED Gold and Platinum, basically based on the drive of the project manager. We're working on trying to institutionalize that more along the lines that UCSF talked about earlier, but still it's primarily driven at that level and not from the faculty. This project was unique in that the viticulture and enology department really saw a connection between sustainability issues in this project and their curriculum and their research. One of the things that Roger, I don't think, touched on was that this project actually involved 2 different departments. The other department really did not see that connection on this project, and one of the challenges from a project management perspective was balancing those 2 very different sets of goals. The other department, I think, was quite had a kind of common fear that we've seen expressed many times, by fear that resources would be diverted from meeting basic programmatic needs to frills of sustainability. Balancing those 2 things was a very complicated process, and integrating that into the design-build competition and delivery process was very tricky. As I mentioned, and as Roger talked about, the faculty in viticulture and enology saw many connections. It's a very unique building, and I think it offered some opportunities perhaps some other projects don't offer. Some of the other things that I think have made this successful is that the faculty of that department is very connected to the industry that it serves, and is also very connected to the donor base. This project is completely donor funded. And those connections to that industry, understanding what's important to the industry, understanding what's important to the donors, knowing who has the money to cough up to make some dreams realized was absolutely critical. And again, we don't see that level of faculty involvement in the connection to the industry and to the donors that we saw on this project. It was absolutely critical. Just a couple other thoughts I wanted to offer. We went with the design-build process, as Roger mentioned. It certainly had its ups and downs. It was not a straight trajectory. It was a very iterative process. This project actually had about a 10-year gestation, I believe. It went through a number of cycles. We went with design-build because some of the key donors were much more comfortable with that delivery method than they were with some of the traditional delivery methods that the university uses. We also, I think, by going that way, allowed this development of sustainability goals to be a much more organic process than it would have been had we gone through a more traditional design-build method, or traditional design-bid-build method. That process did involve or require a great deal of faculty time. And again, this project, I think, is somewhat unique in that this faculty was very willing to participate and spend the time necessary to advance this. So lastly, I just want to thank the team, FLAD Architects and B&B Builders, who won the competition for this. They have been great to work with. There were a lot of loose ends at the end of that competition. One of the big issues was that it was kind of a chicken or the egg thing. We could not get commitments from donors until we had something to show them, and it was a very back and forth process. And we were under strict orders from the dean that we were not to slow this process down. We were to get this thing built. So integrating that into it was quite complicated, but it seems to be working quite well. So, thank you.
Okay, question time.
I had the pleasure of going through Frog's Leap Winery, and they have a LEEDS project, but it wasn't anything like what you've done, and what you've done is brilliant. And it's just for the main, I don't know, tour area. Yep. and what have you. But are you going to do any kind of tours? Do you do it of the existing building? Will you do that of the future structure? It was such an amazing educational awareness just to go through what they've done. And they also have their vineyards as a sustainable vineyard, and I don't know if you have that as well, but if you have any kind of plans to do that, the awareness level was just brilliant, and what you've done is remarkable, because to think of what you've done with the fermentation process, he couldn't even touch that. So he just did the main building where you come in with the tour. So anyway, kudos to all of that, but are you going to do any kind of tours?
Well, firstly, thank you. And I said to Gary and other people, if you know some people who think they're lucky, I'd like to have a conversation with them, because I think I'm luckier. It's a special place and time, a special group of people, special opportunity, and it's important that we do it from a teaching perspective. So it will be an educational environment, as well as a functioning building, as a very precise research facility, as well as a teaching lab. So it's got to be all of those. It's integrated with our vineyard. Our process chemistries, which I didn't get into, which really don't fit LEED, have a lot to do with making it the most sustainable green chemistry winery vineyard ever built, and probably for the next 10 years. So there's many aspects we didn't get into today, which people say to me, why would you do that? What's the point of having a zero carbon building? And the answer is so that with your vineyard, you are the largest negative carbon entity on the planet. That's why, and because we can. And so it's no good in the world of wine saying we're carbon neutral, because every winery that has a vineyard is carbon neutral, so end of discussion. The question is, would you try to capture 65 litres per litre of grape juice every time we ferment when it's pure CO2? Why wouldn't you want to capture it while it's most concentrated? And you only do it for 6 weeks, but in principle, you should do it. And that's why we're trying to do that. But thank you for your comments. And it was the basis of other people in the industry understanding LEED that allowed us to go back to them with the proposals that actually they saw, yes, it was important to go LEED Platinum. So we couldn't have done it without that background. Does that make sense? Thank you. Oh, I'm sorry. All right. Okay.
Firstly, very nice presentation. All the presenters were very nice. Second of all, it's probably a question more for the university related to the delivery. First, what led you in the decision process in terms of what delivery to use to go the design build route? And then secondly, since this building does have the sustainability requirements and very complex process functions in the building, how did you create sort of the bridging documents to select the design, the design builder?
Well, the design build process, as UC does it, allows us to cap the budget at a certain number and then solicit proposals that don't exceed that number. So that was one of the driving factors. The budget for this was estimated at about $20 million. We had total project costs of 16.5, or total project budget of 16.5. So one of the reasons to go with design build was to simply cap the costs rather than go through a very long, lengthy design process and then find out we couldn't afford what was designed. Also, as I mentioned before, some of the key donors in the private sector were much more comfortable with other delivery methods than a hard bid. Some of them were very sophisticated. They had built wineries. They had come from other fields where they had done construction work. In terms of controlling or setting the standards for sustainability, we did, I think, what was probably the most elaborate, detailed program we've ever done at UC Davis for a project. The project itself, even without sustainability, was extremely complex. It had more systems in that small building than any other building we've ever done, and very complex and very unique processes. A winery, we call it a winery, but it's not a winery. It's not like any production winery. It's a research lab, essentially, and a very unique one. And same thing with the brewery and the food pilot plant. So we developed a very detailed program. That program was then put out. We went through a pre-selection process for design build teams. We selected, obviously, for teams that had experience in these building types. We narrowed it down to a field of 3 competitors. We did a competition. We paid a stipend. We took a fair amount of time. I think it took 3-4 months, Roger, approximately, something like that. So we gave them a fair amount of time to go through that. And the presentations were outstanding. I mean, the work of all 3 teams was really outstanding. We had great teams. All of them threatened, I think, to pull out at various points because they felt they couldn't make the budget. But they all did. And then towards the end of that process, it got very complicated because we started to get some real feedback from some key donors that they were willing to donate more money specifically for sustainability. We developed a program to generate interest and show them the options. That was very interesting, and the response was very good, but it was very complicating to the competition process because we didn't know how to integrate that into the competition in part because the dean and the other department did not want that to be a factor in the selection. They did not want to skew the selection process based on that. So in the end, we selected the teams based on their base case for the base program without going to LEED Platinum. As it turns out, they all proposed gold. And then we've been in the process of redesigning and negotiating the additional donor funds of about $2.1 million to bring it up to the platinum level.